Hello, this is Mr. Stansbury. I'm going to take you to the 10B Part 2 worked problems here. So let's start here with number 1. Find correct to 4 significant figures, the unknowns in the following. So they want to just know what in the heck is this side length right here. Now, this whole chapter, if you'll remember, is all is dealing with right angles. And if you'll notice in here right now, we don't have any right angles. So what we need to do is actually we need to create a right angle. So if we just take this here, create a right angle right there. Now we just kind of ignore this triangle over here and we're just going to look at this triangle here. If we cut this exactly in half, this is now 2 centimeters, right? And we are going to be looking for this side here, which is the hypotenuse. So here's our angle. That's the hypotenuse. This side here is the adjacent. So with our friends SOHCAHTOA, we know that, let's see, we've got adjacent and hypotenuse, that's cosine. So we're going to do cosine 61 equals adjacent over hypotenuse. Oops, our adjacent is 2 over our hypotenuse, which is going to, if you'll notice here, this is an isosceles triangle, so this length here is going to be the same as x. That's what we're looking for. Okay, so if you'll remember, if you have the variable is in the denominator, our easy way to do this is just to switch these two spots here. So we know that the hypotenuse here is going to actually equal 2 divided by cosine 61. All right, so we bring up our calculator and we go 2 divided by cosine 61, and that gives us if we're looking for 4 significant figures. Here's the first significant figure, so 1, 2, 3, 4. We're going to round to that spot there. The 3 tells the 5 to stay the same, so it's 4.125. And it's centimeters. Okay, so we have found that one out. Let's look at the next one here. Number 2, find the unknown value of the unknown in each of these here. So let's take a look at A here. We're trying to figure out what that angle is here. So this is a radius. We can also draw this over here to also be a radius. So these two are the same. So then that means this here, if it's dropped down at a right angle like this, cuts this side exactly in half. So this now is 4 centimeters. Okay, so if we're looking for that angle there, this is the adjacent, this is the hypotenuse. So SOHCAHTOA with adjacent and hypotenuse is cosine. So we would want to do cosine theta equals adjacent, which is 4, over hypotenuse, which is 5. So we will use our handy dandy calculator to do, we're looking for an angle, so it's second cosine of 4 divided by 5 gives us 36.86. And it says find the unknown value. It doesn't give you, tell you where to round it off, so I would usually go to the 10th if they don't tell you where. So 36.86 would be 36.9 degrees if we round it off. So theta equals 36.9 degrees for that one. Okay. B is a similar type idea. These are both the same. So if we take this and draw that straight down here, we cut this exactly in half. So we can say this is 10. And then this angle also actually gets cut exactly in half. So if we take 124 and we divide it by 2, we're going to get 62 degrees for each of those there. So if we redraw just this triangle right here, we've got this here, that's a right angle. This is 10 centimeters. This is 62 degrees. And we're trying to figure out what this is here. Right? So from that angle, this is the hypotenuse. This is the opposite. So opposite and hypotenuse is sine. So we would want to do sine 62 equals opposite, which is 10, over hypotenuse, which in this case is r. The variables in the denominator, so these two are going to swap spots, and we'll get that r is going to equal 10 divided by sine 62. So let's see what that gives us. 10 divided by sine 62 gives us 11.3 11.3. So we get R equals 11.3, and it's centimeters. Okay? Okay, let's move on to the next one. We got number 4. A chord of a circle is 13.2 centimeters long, and the circle's radius is 9.4 centimeters. Find the angle subtended by the chord at the center of the circle. So, let's draw this thing as best we can. We got a chord that's 13.2 centimeters long, so we'll just do this. We'll call that 13.2 centimeters. That's a chord. It goes from one side to the other. Doesn't necessarily have to go through the middle. That would be a diameter. The radius is 9.4, so we can say this is 9.4. And just to make this easy, I'm going to draw this over here also at 9.4. Okay. Find the angle subtended by the chord at the center of the circle. So what that means is we are going to be looking for this angle measure right here. That's the angle subtended by the chord at the center of the circle. Okay, so that's what we were trying to figure out. So we're going to want to do what we've been doing on these other ones. We're going to cut this in half here. So then we cut this angle exactly in half, and we cut this side exactly in half. So half of 13.2 is 6.6. So if we're looking for this angle here, we'll call that theta for now. We know that this here is this side here is the opposite, and this is the hypotenuse, right? So using our SOHCAHTOA, we have opposite and hypotenuse, so that's sine. So let's do this. We'll do sine of theta equals opposite, which is 6.6, divided by hypotenuse, which is 9.4. So we're going to want to do second sine of 6.6 divided by 9.4 gives us that this angle right here is 44.59, but we don't want just that angle there. 44 point, what did we say, 44.9? Oops, sorry, let's see. That's what I'm trying to click on. 4.59, so 44.6, right? But we want to know what this entire angle is, so we just have to double that. So we'll just take our answer, multiply it by 2, and we get 89.195, so it's 89.2. So the angle is, 89.2 degrees. Okay? Okay. Moving along to the next one here, number 7. The diagonal and a longer side of a rectangle make an angle of 43.2. So let's make a rectangle. And it says that we need the diagonal. So the diagonal and the longer side of the rectangle make an angle of 43.2. So that's going to have to be, like, say, this angle here or this angle here, because that's one with the long side and the diagonal. Oh, the diagonal, which is the hypotenuse. So let's put it here, 43.2 degrees. If the longer side is 12.6 centimeters, so this is 12.6 centimeters, find the length of the shorter side. So we want to figure out what that is there. And there's our right angle. Okay? So that's the hardest part of these problems usually, is setting up the picture correctly. Okay? So this is what it's going to look like. Let's get our SOHCAHTOA back up there. All right, so there we are. So we've got this side here from that angle is the opposite, and this is the adjacent. Okay, so opposite and adjacent is tangent. So we're going to want to do tangent of 43.2 degrees is going to equal opposite, which is x, over adjacent, which is 12.6. Since our number is on the bottom there, the value that we know is on the bottom, we can multiply both sides by 12.6. And that's going to tell us what this opposite side here is. Okay, so we're going to do 12.6, and then tangent of 43.2. Right, 12.6 tangent 43.2 gives us 11.8. Okay, so x equals 11.8, and what is it, centimeters? So the shorter side is 11.8, this piece right here. Okay, all right, moving on to the next one, number 8. A rhombus has diagonals of length 12 and 7 centimeters respectively. So let's draw ourselves a rhombus. So if you'll remember, a rhombus is basically just a squished square. So that means that all these sides here are all the same. And it says one diagonal has length, I'll pretend that's a diagonal. That diagonal's got a length 12. And then this one, the shorter one, is going to have a length of, say, 7. Okay? Find the larger angle of the rhombus. So we're trying to figure out what the heck that angle there is, or this one. They're both same idea. Okay. So nice thing about a rhombus is that the two diagonals not only bisect each other, so that this length is the same as this length, and then this is the same as this, but also these all form right angles here in the middle. So if we take a look at just this piece of the triangle right here, let's just redraw that. So we've got that part right there. We know that this whole length all the way across is 7, so half of that is going to be 3.5. This whole length all the way across is going to be 12, so half of that is going to be 6. And we want to figure out what this angle here is, right? And then if we double it, then that'll be the larger angle of the rhombus. So from this angle, this side here is the opposite. This side here is the adjacent. Okay, so with SOHCAHTOA, let's see, opposite and adjacent is tangent. So we're going to want to do tangent theta equals opposite, which is 6, over adjacent, which is 3.5. All right, so to figure out an angle, it's always second tangent, and we'll do 6 divided by 3.5, and that gives us 59.74. So we'll go with 59.7. 59.7 is this angle here, but again, we don't want just this angle. We want both parts, and these are both identical. So we just need to take this answer here and multiply it by 2, and we get 119.5 degrees for the whole angle. So the larger angle is, what did we say that was? 119.5 degrees. Okay. Okay, that takes us to our last one, number 10. We've got two parts here. Find the value of x. So we got to figure out what this is here. Okay. Now the handy part about this here is that these two sides are parallel. So if we draw on here a line straight down here and make that a right angle, then this up here also has to be a right angle, because these lines here are parallel. So what we'll want to do here, the value of doing this here is we can figure out what this value is here. Oops, not x. Let's call this, say, y. If we know what this is here, that's going to end up being the exact same as this value here. Okay, so what we want to do is find this y here, and that's going to be the same as this here. And then once we know this side here of this right triangle, we can figure out what that is there. All right, so let's find this one. Let's find this y here. So from this angle, this is the opposite. This is the hypotenuse, right? So we've got opposite and hypotenuse, that's sine. So we'd want to do sine of 70 equals opposite is y, hypotenuse is 3. Multiply both sides by 3, and we'll get what the y is. Okay, so we get 3 sine 70 gives us 2.819. So I'm going to go 2.82 just to give us a nice accurate answer. So y equals 2.82 meters. So this is 2.82. And since this is 2.82, this is also 2.82 over here. Okay? So that helps us out a lot because we don't have enough information with just this here to figure out what x is. We need another side, or just so that we can figure out what that side is over there. So from this angle here, this is the opposite, and this is the hypotenuse. So we're going to do, for this one over here, we're also going to do sine. So we'll do sine 55 equals 2.82 over x, right? So again, if the variable is in the denominator, I know that I just switch these two things here, right? So I get x equals 2.82 over sine of 55 is going to be what that length is there. So let's figure that out. So we got 2.82 divided by sine 55, and we get 3.44 meters. Okay. All right. Last one here. We can do the same thing here to find this angle. We're going to want to draw this here, make that a right angle. This value here. So we know that's why we do the same, make the same thing over here. Since these lines are parallel, we know that this will also be y. So let's figure out what that side is there. Okay, so we've got, here's our angle. This is the opposite. This is the hypotenuse. So opposite and hypotenuse is sine. So we'll do sine 70 equals y over 5. Okay, multiply both sides by 5, and we're going to get y equals 5 sine of 70. Let's go over here. So 5 sine 70 gives us that y is 4.698, so let's go with 4.7. Right, so that's 4.7. This is 4.7 here, so this is also 4.7 over here. So to find that angle, this is the opposite. This is the hypotenuse. Right, so opposite and hypotenuse is sine. So we're going to want to do sine of, not theta, but alpha is going to equal opposite, which is 4.7 over hypotenuse, which is 6. And then we can figure that one out. Okay, so again, we're looking for an angle, so it's second sine 4.7 divided by 6 gives us that angle. Our angle there is 51.56, so I'm going to go with 51.6 degrees is what alpha equals. Okay, that takes us through the end of 10B Part 2. If you have any further questions, please feel free to ask in class. Thanks.